know, today it is about astrobiology and planetary geology. So this is going to be a great opportunity for you who are interested to know a lot about this field. A senior scientist in astrobiology who is the CEO of South Asian Astrobiology and Earth Sciences Research Unit, Mr. Aravinda Ravibhanu Sumanarathna, joins us today as the resource person for the session. Sir, I warmly welcome you on behalf of SEDS Chapter. And also, I welcome all of you for joining for this session. So, Mr. Aravinda, I invite you to continue the lecture. Over to you, sir.
Right, okay. Am I audible?
Yes, sir.
Okay, thank you so much. So, give me some time to share my screen. First of all, actually, thank you very much for inviting me to having a little discussions with the SEDS. Actually, I have been already having some of lectures with the SEDS group. Actually, this is the first time I'm just involving with the SEDS Japura. So today, basically, we are going to be discuss astrobiology and the planetary science, like planetary geology, basically. So it's going to be kind of quite exciting, and basically I'm just looking for discuss especially like the things that we have been done because of the case, and most important thing that we have to be clearly understand how we can do in the astrobiology practical application implementations in South Asian region and things we have been done. Those are the things I'm going to be explain. For the first part of my session, I'm just going to be explain a little bit things relevant to the history of astrobiology and the planetary geology. Then we'll discuss some of basic applications that we have been just ongoing. I hope you can see my screen. Is it clear?
Yes, sir, it's clear.
Okay, thank you very much. So I'm going to start and another important case. I'm just trying to continue this session from the English, but any of corrections from the Sinhala, it's the discussions is open at the end. If you guys have any kind of matter, the things you may open to discuss via Sinhala language also. Okay. Things actually basically when we are just discuss with the astrobiology and some of factors like planetary geology, so those are some of kind of curious things because of it's relevant to the life outside of the planet Earth, because of life beyond the planet Earth. Actually, these are some of preliminary questions that you guys have when you discuss of the astrobiology. Because of the swing, we are so curious of the life beyond the Earth, and also if it is any other life outside of the planet. Those are the things people are very curious, as well as scientists. The other important case, it's so hard to give a definition for the life. So still we are doing some of only simulation. We don't have like exact definitions and some of like exact confirmation, yes, there is a life outside of the planet Earth. But the some of curious question as displayed here, how its origin evolved, and what kind of extreme conditions that affect into the life. Those are the things actually we may have to be just think as a scientist, even though some of the other people also, they also really interested to have like these kind of things and discuss like aliens, because of that is something like common phenomena when we discuss the astrobiology. But this is not something like aliens. because of this is something like very scientific subject that we are going to study the life beyond the planet Earth. So that's why I just need to just explain few of basic questions. Actually, those are the questions. Even though currently all the people who have in how it's habitable, evolution, as it all like extreme, what kind of extreme condition, what kind of microbial beings outside of the planet Earth. So we'll try to discuss on today's session what kind of things in outside of the planet Earth and what are the simulations that we can do for finding those things. So basically, actually, when we discuss of the astrobiology, they do have some of a format. Because of these are some of signatures. It's you might have to just think like it's not specific to the one subject. Example, I will just explain later. If you want to be astrobiology, it's what you have to be done and what kind of knowledge you need, and also what kind of research background and what are the things that you need to get as an experience, and also the things that component with the astrobiology. It's something like very unique. It's not only customizing to the very just one subject, even though you can see in here like it's something like very hard to explain some of definitions when we discuss of the astrobiology, because of sometimes we may have to be focusing with the part of the planetary protections and some of extreme conditions on the different type of planets and what kind of biosignatures in have, especially the conditions of the habitability, because of comparative with the planet Earth, currently how we are living. So we do have some of a lifestyle, and we just seen some of trees, rivers, and also some of a different type of animals. So those are the our habitable life, and same time we have some of prehistorical references, because of those prehistorical references are so important. That's what we call in here life detections, because of the considering the evolutions of the planet Earth. When we just go back to the 4.5 billion years ago, we do have some of a geological timeline, as well as some of anthropogenic activity. It means like the things that done by the human. We have some fossil evidences and different type of geological era and what will happen on that period, and it's really interesting. So as well as when we are studying on the outside of the planet Earth, so same phenomena we have to be following. So basically, I hope all you know the astrobiology is something like study of the life beyond the Earth. So these are the things that what we are doing, and also same time it's a combination to the planetary geology, because of why I'm really interested to discuss on planetary geology. It's discuss only the materials on the surface of the planet, because of example, if someone just asks to just do the sum of study on the gas giant, just like Jupiter. So that subject is not belongs to the planetary geology, because of this is something like the case we don't have any solid materials to study on the Jupiter, but especially when we are study on the planetary geology subject. So what are the base component that we have? It's our moon and the Mars. So even though some of our research also focusing on those two planetary items, the case we can just clearly identify solid materials. So without solid materials, there are a lot of research you can see relevant to the astrobiology. Like if someone interested to study on the atmosphere, on the other planet. Actually, this part is not directly involved with the planetary geology. That is a part you have to be just understanding the difference between astrobiology and the planetary geology, because of astrobiology is something like very deviated subject, so studying the life beyond the earth, and the customizing subject, a planetary geology, which is helping to the focus into some of surface material on other planets. Not only the planets, even though some of like meteoritic things like comets, so all over the things, and definitely you have to be, it's soluble things, you have to be just touch, but the gas and other things you can be just touch and you can nakedly see. So those are the different of the astrobiology, planetary geology, and other subject. And also these are the some of framework. So that my next question, if someone interested to study these kind of things, what we have to be do as an astrobiologist, what kind of person can be like astrobiologist, like I mean like what are the basic things astrobiology have to be done. This is something like very curious one, because of I will give you some of a preliminary example. The things that you have to be think if you really need to be like astrobiologist, what are the background that you may have to be develop. The first thing, actually a very preliminary thing, definitely you may have to be like a broad range of scientists. It means like multidisciplinary science. If I study in the astrobiology, even though you need to have in some of basic the idea of the microbiology, and also same time a paleontology, and also a geology. So actually these kind of three components are very important if you're really interested of the astrobiology, because of if it is some reason a microbial activity around in the outside of the planet, definitely you have to be a capability to understanding. But if it is any kind of projects ongoing with the international level, there are some of customizing scientists which is helping to the clarifications of the each subject. Just like there are some specialists on microbiology field, and also especially a paleontological fields, even though paleontology is something like very deviated subject, like if someone interested in analysis in the trace and the sedimentations part and the some of fossilizations part, it's something like gradually customizing. So as a basic components, as I told you, the astrobiology should be something like a broad range of scientists. Next thing is something like you can see fundamental question. What is a fundamental question? Searching the life beyond the earth. We have to be just responding to the finding some of strategic answers which is relevant to this fundamental question, and you may have to be develop some of a simulation in between. It can be happen like Mars and Moon, because of when you are studying the astrobiology, Mars is the best resource that we have to the implementing some of very standard thing. And also same time publications with some of our exact scientific data. It can be happen a different because of I will give you two examples, then you will have in some of very clear idea. There are a lot of astrobiologists, they working in a very separate mode. Some of astrobiologists are incorporated because of NASA astrobiology. It's something like they have specific framework, and if you are just concerned of the Royal Astronomical Society, they do have another framework. And if you are concerned of the some of astrobiology field in Asia, they are just working on different subjects. So what I want to just mean, maybe you guys have been just remember in last year, so there are some of evidences for the life we do have just find out from the Venus atmosphere. So that is the things that basic thing like the scientists from the Royal Astronomical Society, and they have been announced, yes, we have some of organic compound from the Venus atmosphere, but that part is not belonging to the planetary geology, but it's not because of the soluble part. And also same time, that's why I always advise into our student, you may have to be just steady with the some of good references and the dive in the subject, because of the reason. You see, even though I remember in 2012 or 2013 there is an astrobiology conference in Sri Lanka. I think it's almost now 8 to 9 years ago. I was there. That conference held on the University of Peradeniya. Professor Chandra Vikram Singh also there. The surprise thing is, still I remember he also discussed very similar thing which is relevant to that atmospheric component on the Venus. So my question is, but he didn't publish anything in the highly impact journal, but philosophy is there. That's why I told you some of scientists are really interesting and they just go through with the subject and finding the data analysis, and some of are not publishing. But after publishing, that it's very clearly go through our audience, like people, and they know this is happening with the scientists and they are just find out something newly thing. So it's very important case, but philosophy is already there. The verification is happening after the publication. Same phenomena, it's happening. Another example I will tell you, like when I was studying at the postgraduate institute in University of California in 2014 and 15. There is a very interesting fact relevant to the archaeology, and I heard from some of my teachers. Yes, Sri Lanka, we do have something like tools having a very specific the modernisms in like a Pahiyangala, which is belong to the Balangoda man, and it's almost exceed 14,000 years ago. That is something, it means like these kind of like a prehistoric tool first of all developed in Sri Lanka. That is the basic idea of that story. However, none of are not published it. The philosophy and the data and all the things may be available, but it's not that much enough. But before a couple of years ago, one of scientists in Sri Lanka, he published with the Max Planck Institute and verified the same phenomena. That's why I tell you, as a student, you need to go through with that philosophy, because of if someone have a philosophy, definitely you have to be observe it. It's not just coming from the reading a scientific paper. So it's just some of like example to understanding the any kind of subject. It's not only for the astrobiology, even though other subject can be just having this kind of things. Just wait. Okay, we'll shift into the next one. And actually, as I already told you, like I'm just trying to explain some of like historical things of the astrobiology, and then shift into the Sachin, are you there? It's someone just looking for the screen sharing. What should I do?
Doesn't matter, sir. You can continue, sir.
Okay.
Thank you, sir.
And we'll continue the session back to the prehistory background of the planet. Right now, we do have some more fundamental idea of astrobiology and the planetary geology, and also what is some of responsibilities of the astrobiologist and what kind of person is called astrobiologist. And also same time we'll see what kind of prehistoric background and the paleo background that content in planet Earth. Actually right now a planet Earth is I think almost 4.5 billion years old. So when we considering of the life of the planet Earth, definitely you may have to think of our sun, because of the considering of the our sun, it's something like a G2 type star. So how it's generating the energy by using the converting hydrogen to the helium by nuclear fusion reaction. Those are the some of fundamental things, but it's very important when you are studying the life, because of if you are back to the 4.5 to the 3.5 billion years ago, there is no human, even though there is no mammals, no reptiles, even though in the planet Earth. That's what we call some of extreme condition we can clearly identify on our planet Earth before 4.5 to 3.5 years ago, and randomly it happening when we are just concerned in the geological time scale. Randomly it's happening, and there are a lot of evidence in Sri Lanka also. We can just follow up by using the fossil evidence. So in here basically on that time we can just identify some of atmospheric gases, not like today, because of the scenario, it's totally different and very extreme atmosphere we do have. It's contained with the nitrogen, methane, ammonia, and some of carbon dioxide gases, and also like a gas type in H2O. That is what basically we call primordial soup. Because of, I hope you everyone have idea of what is the meaning of soup, and it's all the things just contaminated with the one bucket, and it's made up a different taste. So but however, this is very interesting. What is the conditions of the our paleo atmosphere, and how it is just put it to the one space bucket. So that is the part we may have to be thinking, because of this is something very interesting, symbolizing a part of the when we are just discussing of the planet, because of its all the component which is supporting to the develop one organic compound. So that is the something very unique and turning point in planet Earth with the current data. Because of if someone asks how nitrogen came to the atmosphere, like methane came to the our atmosphere, and ammonia, it's question. That's what some of scientists explain from the theory of the panspermia. Because of by using the sum of meteorite, it can be delivered to the place to place by different type of organic compounds. I will explain you, because of there are some of applications practically we have been developed to use in those kind of things, but not only for the verified life, but currently we use those kind of extreme thermodynamical scenario for different type of industrial purposes things. Later on I will just explain, because of it will be something very interesting. So actually considering of those atmosphere, this is what I just explained, because of at the very prehistoric time, considering the 4.5 to the 3.5 billion years ago. So those are the things have been just contained in the atmosphere. So you know that urea and millet, it's something like very a turning point of the life and the astrobiology, because of those are not verified what is the meaning of the life and the definition for the life. I believe even though next 100 years none of scientists are not able to give in a definition for the life. It's so hard thing, because of all the things we going to be compare the things that we have been just find out on planet Earth. That is the things you may have to be understand. Just imagine somehow reason if all the people just lived in planet Mars. So all the data that we are just find out from that same place, not from the planet Earth. Then what we are doing after we just find out that these preliminary and fundamental data, yes, we know there are some microbial activities like this, and this is something behavior of the reptiles, mammals, and other things. And what we are doing, we just trying to be compare those data with the other planet. So the point number one, it can be mistake. That's what we call a simulations in between two planets, even though currently we are also doing, but we had to be so smart and find out with some strategic method when you are doing those kind of, because of without having a similar condition, there are some opportunities and some of possibilities to creating the some of life form. So that is the part we may have to be understanding. But this case at the end, as we know, so they have been just clearly identify the after combinations of those compound at the end amino acid, because of that is the most important thing, the by using the sum of these kind of prehistoric atmosphere gases like ammonia, methane, carbon dioxide and all the things, with the sum of sparkle things, like at the very prehistoric background also there are a lot of thunderstorms and all the things, and the molecules that content on the atmosphere, it can be just divided to two different parts, and it's combined with the two different like a different type of reactions, and finally it did to some of like primordial soup with the water. So after having a sum of extraction, they just find out the amino acid and as a sum of very turning point of the life. So this is the fundamental idea of the Uri-Miller experiment, and I hope most of our students have some basic idea of this case. But the why we need this kind of experiment, even though when we are just studying the planet Mars and all the things belongs to the life, so those experiments are very important. But the things that we may have to be just think a different type of atmosphere and different type of solidable surface of the planetary geology, it can be different. Actually, that same application few scientists I think last year they have been applied to the Venus. And they just find out some of organic material from the Venus atmosphere also. This is very interesting part, and currently we do have just explanation, so the summary of what I have been just discussed. Like at the very beginning we do have some of a microbial life in planet Earth. After that it's converting and evoluting, and still we can't say those species. I don't know actually how many species currently lived in the planet. There are a lot of species like animals, the microbial species, and a lot of trees. Some of are arguing like those species individually pop up. Some of us say no, it's having some of interconnections with each everyone, and it's not like individually pop up, and it's gradually evolution happening with the sum of a series. And also, as I already just discussed, like it can't be happen like that. So other scientists are arguing. However, this is very interesting, relevant to these kind of like a geological timeline starting from the 4.6 billion years to today. Right now we are in the Holocene period. At the end I will discuss some of little things on the Holocene and Pleistocene in Sri Lanka currently that you are working some of application. So actually the things before I shift into the application part, what you guys have to be think. You see, currently it's almost 4.5 billion years exceeded. It means starting from the our planet Earth, currently we are in the middle stage. Another 4.5 years we do have to be spent. So you guys have to be just think what will happen after next 4.5 billion years, because of practically without having any unstable scenario, our sun can be just stably generate the energy by converting the hydrogen helium by using some of nuclear fusion reaction. The same time what will happen, the planetary habitability around the planet Earth. That is the part you may have to be just think better than we just find in the life outside of the planet Earth, because of when you are doing some of simulation, this part actually made us something very curious, because of we just forget it. We do have another 4.5 billion, and what are the things we can be study relevant to those parts. So it's up to you actually just think and find some references and just go through with the subject, dive in the subject before you just searching the outside of the planet Earth. Just try to be just heading with some of a prehistoric and paleo background on the planet Earth. Because of in Sri Lanka also, maybe you guys don't know, still there are a lot of evidences we have some very interesting fossil evidence until Miocene period and Pleistocene and Holocene. I will explain you later. Because of those kind of extreme conditions and some of depositions will help us to explain some of very interesting simulations outside of the planet Earth. Right now we'll discuss some of things relevant to the extreme conditions and the applications that we have been developed currently, that I hope you guys having some of the fundamental idea of the how history of the astrobiology and how important to study as an astrobiologist, those kind of things currently. So we'll see what are the extreme conditions. Like I'm not going to be like very hard explanation. This is very simple because of you have already seen like how it's something like very cold conditions in planet Earth, very extreme hot conditions in planet Earth. Maybe it can be like very hot hydrothermal wind on the planet, even though like under the sea bottom there are a lot of things. So even the tornadoes, hurricanes, just like in here, there are a lot of things. It can be like acid rain. Even though that image is represented in here, it's not Mars, it's from the Yellowstone National Park. So very interesting things, because of when you're studying this of very extreme conditions, like especially like the microbial organisms, or you see some of it, it's very beautiful, like how it reactions with the different type of gases, and when it's having a freezing period, so it's contaminated with the some of soil, and the change in the colors, it's displays something like very unique formation. And also it is something like very interesting tourism site. You can see at the top bottom like a top corner of the image, there is some of like very tiny road to the some visited who are around in this Yellowstone National Park. It is very interesting thing, because of this is something like a very unique astrobiological resource places that open to the each every people in the world. So what I need to be just explained right now, I'm just trying to be discuss something applications that we have been just developed for the astrobiology, and some of things practically we have been just applied to the another subject also, like giving the sum of like a multidisciplinary solution. Originally some of solution we have been just providing to the astrobiology cases, but the secondly a same solution with the sum of customizing things we just providing to the another sort out the another matters. So we'll see what are the things that we have been just done. So this is something very interesting project in last 5 years that I have been just cooperated. So it's from the Kashmir region, we call it Ladakh, and objective of this project to study some of very unique bacterial formation inside of the ice. Because of this area is something very extreme cold, you know, at the night sometime it's going minus 20, 30, 50. It's almost like something like Olympus Mons in the moon, like Mars, because of the way of behavior of the temperature parameter. It's so different, because of in the summer it can be just 15 to the like 30 to 20 degrees, but the case at the summer of winter, even though this period is it's very cold the area, but it's very interesting landscape to study. Some of very interesting, one thing it's based on fossil, other one is based on some of like any kind of extreme movies, because of the some of there are huge and the very systematic and strategic ice layers very compactly deposited around in the whole region. Because of this is something like eastern part of the Everest. So we have been just start to 2015 this project. So actually this is different story. What I said, that objective is the project is finding those kind of extreme microbial activities inside of the ice. But at the middle of the project we just shift in another part, but currently that microbial part also just ongoing. Same time we providing by using those kind of ice to the water conservation matter. Because of this is something like very high altitude mountain. You can see it's dry mountain, other one is high altitude mountain. It's more than like 5,000 to 6,000 meters from the sea level. So it's so hard to find in the water at the summer period for the people who live in this area. So what we have been done, we create artificially ice in there. We call it artificial stupa, or otherwise artificial glaciers, and at the summertime it will be going to be melting. I'm not going to be explain like some of mechanism that you have been just done and all the things, just take images. Because of this is something like very interesting technique, a natural technique to conservation water in high altitude mountain. Because of this is very extreme condition. This is the first team that cooperated with this project, and at the summer this ice stupas, so they're just going to be melted and just catch up with some of a natural stream. Actually it is something like temporary store. Because of, you see, on that some of time we do have a lot of water in this area, some of period, but some period there is no water sources. All the things are freezing and other things and vaporizes. So what we have to be done, we have to be just find out some of solution for store those things. We can't just put in those water into the some of tank, because of it's so high altitude, and it can be having some of landslide and all the things randomly. It's very risky one. That's why naturally we can just freeze the water, but it's converting to the like this kind of ice stupa, and after it's having a summer period, it's melting and just catch up with the current stream. Very interesting project. And you can see, if someone interested on the some of basic things, you can just go through with this technical report, like modeling ice stupa and architecture of the pagoda. I think few years ago I have been just documented this technical graph, and this corner you can say this is our new site from the Manali high altitude mountain. Also same time this is very interesting paleontological sites. There are some of fossils also available in here, and this is the things that we are doing on the Kashmir region. I will explain a little bit furthermore. So actually this case is from the similar side to stimulating a landslide impactations on moon and Mars. Because of this case also we have been developed artificially, and we just trying to be get some idea how landslide and other things happen, especially regolith formation in geology. So we just trying to be compare this formation and some of sites in moon and the Mars. Because of we just referring some of data from the NASA, and few of NASA scientists also directly cooperated with the like mega landslide project in Mars. So however it's very interested, very interested project, and actually these are the things we call it simulation project. Because of before we just head into the Mars or moon or doing the things, so what we are trying to do is like doing the simulation. Because of simulations are very important, even though NASA scientists are also doing the same phenomenon. They also just selecting very specific sites in on planet Earth, and they're doing some of simulation before it, even though especially like designing some of robotic parts like rovers and all the things. You can just see they just, as I told, like they just having the simulations with those sites, even though like those rovers, they just put it to the ice and they just run into some of high altitude mountain and just try to be just processing if these rovers are working with those kind of temperatures. So those are the things we call it simulation. It's very, very important one to get some of idea. And same time simulations of the other fossilized item. You see, like when you're concerned of the microbial activities and some of other paleontological activity, it means like we call it fossilized activities outside of the planet, especially in Mars. Because of Mars, we have different type of structured formations. Still we are unable to explain those things, and even though some of explanations in NASA and some of other space agencies, so it's having a doubt. And what those institutes are currently doing, they're just asking to different type of scientists like astrobiologists, ectogeologists, and many scientists. They just cooperated with them and try to give new definition with the new technology and having a new idea, and especially like reading like XDR reading and EDR reading of the image. It's so important because of at the very beginning those kind of things are not currently developed, but right now we do have a lot of technology, new ideas are coming, different type of institutions are incorporated. It's very important. Just like these kind of things are very important. At same site, actually in 2019 I have been just taken those things from the Kashmir Ladakh site. There are a lot of like ammonites fossils contaminate with this landscape. Because of it's very important to having an idea of the prehistoric background of this landscape, as well as you can see in here Nibra Valley, the how it's a formation and happening, and a landscape of this mountain and regolith formation, and if it is happening some of landslide, how it's happened, and basically we call it the alluvium sediment. Because of this part is very important when you are studying the Sabaragama basin. Because of I hope some of our students having an idea. In Sri Lanka, we have fossils belongs to the Pleistocene period. So when we concerns of the alluvial formations in the gem pit, these kind of formations are very important because of same scenario happening in Moon and Mars. Because of some of very dusty layer, how it's going to be with the landslide impactation. It's really interesting pattern to study. However, it's very interesting. And here also another the ammonite one that previously that we have been just find out from the Ladakh side, and also the currently what we have been just discussed, it's belong to the paleontology, fossils and all the things, and simulations with the different type of a planet. And most important case, exactly we have to be just find out the extreme places and the next. So in here also it's almost like Mars, but this is the same site from the Kashmir Ladakh. It's not the Mars. You can see the landscape in here and the background of the geology. A perfect place for study of planetary geology and the simulation. And what the things that we have been just done in last year by like Mumbai Amit University and the people, they have been just created some of Mars simulation program. Actually this is the first Mars simulations program in South Asia region, and they have been just created a Mastoc special rover, and they just put it on that landscape and just trying to get some of very interesting reading and all the things. And actually those are some of practical things, even though NASA and other institute also doing before they just send into the robo or whatever the item into the outside of the planet, because of its processing via extreme conditions on a planet. It's compulsory, because of that. After that we can just get some of idea how it's happening and why this designing is not going to be like acceptable, and the things like that we can just having a very basic idea. And also same time, after we just head into the Ladakh or that extreme condition, we can just have in a different type of parameters. The most important case is this landscape content with some of hydrothermal wind. So that is very unique one. Even though Sri Lanka also we do have hydrothermal activities in some of area like Trinco and other places. So just like this is something like very high altitude hydrothermal activities you can just see, and some of students which is cooperative with this project, they just trying to get some measurements like the pH, like some of pH value, TDS, how the water behavior, and the salinity. Actually it's very important, because of it's all when you concerns of the daytime and nighttime for this area, it's almost like upside down, because of even though daytime in like winter period it's at the like 5 to 1 centigrade, but in the night time it's very cold, and behavior of some of these fragments around the landscape, it's going to be so changeable. Same thing happening on Mars, because of there are huge gap on day and night temperature. It's directly affecting to the surface material, and how some of materials are going to be melting and all the things. So these kind of places are really important to having an idea to what happened on the Mars, Olympus Mons, and all the things, because of still we do have some of images from the outside of the planet like Mars and our moon. So those images are really important to having a systematic simulation based on these kind of places. So also this is not only the one and only place in simulation site, there are a lot of simulation sites in the world. So here another simulation site in Hawaii, and also especially I need to mention like Chile, because of a few of scientists that working with us from the Chile. They also have very interesting landscape to having a simulation part. Simulations mean like it can be used in a math or robotic items, or some of like a physical chemical method. You can just do anything which is relevant to the like outside of the Mars or like a moon, because of things what we have to be do after we just arrival to the like extraterrestrial planet. There are some of protocols and things that we have to be do. So these are the things we are doing in simulations to get the idea how it's going to be a process. So this is the basic thing. And also in here also you can just see some of a very similarity pattern on Ladakh side. Another one is from the Mars. So and here you can see another Mars simulation in the brownish color one. This is from Ussangoda in Sri Lanka. Why it's become like a brownish one? Because of a serpentinate rock. This is something like very extreme condition. I hope some of our students might be visited to this place in our down south area. It's very interesting place to study some of astrobiological simulations thing, because of one corner is border to the sea and the some of geological formations, the things it's happened. It's very interesting, because of it is something like in the border of the other highland complex. That's what I already mentioned you, a basic knowledge of the geology and the paleontology and things are very helpful to understanding some of simulations and the astrobiological thing. And same time I need to be explained. Last year we have been just cooperated with the one of project called 𝗰cie𝗲𝗰𝘁. Actually it's not directly interconnected with the astrobiology field, but it's very important turning point in Sri Lanka, because of in next year we just planning to the having some of a competition, because of the one who going to be win the competition, it's having some of opportunity to ascend into the ISS, like International Space Station. Actually 𝗰cie𝗲𝗰𝘁 project is like incorporated with the many institutions like space industry in the world, like handling by the NASA and 𝗰cie𝗲𝗰𝘁 group. So this is going to be something like very huge, a turning point, like a simulation part, as well as giving opportunities to the different people, people who are interested in this kind of subject. They can just try for this one. And I think Sri Lanka also have something very good opportunities to our student to apply this case on end of the next year. So then we shift into the newly part. This is something that we have been just finalizing a couple of months ago, because of this is what we are called EDR, data from the Mars Opportunity rover. Right now, just keep it in remember all the time. I'm just trying to be explain some of applications, a multi-dimensional, multidisciplinary application that we have been developed, which is relevant to the astrobiology. So currently we have been just discuss some of things in Kashmir, Ladakh, and simulations, designing robots and running in the very extreme conditions. Now we are shifting to the planet Mars. So those images are from planet Mars. So right now here the challenge. So after we just doing all the simulations and all the thing, here we got the data from the Opportunity rover. So we had to give some explanations for this case, because of on 2017 and 18 NASA just going to be just explain a lot of things around in this fragment, because of some of data still not public, because of this is something like very raw data images directly captured by the NASA Opportunity rover. They have been just fast view of images for us, giving ideas and taking the ideas from those trays. Actually this is very turning point of astrobiology field, because of you know that this project is belongs to the Meridian Aquarium in the Mars. It is some sort of like a dry sea on the Mars. So these are some of very interesting components that we can just find out from the Mars, because of just imagine the scale of the sum of objective. It's very close to the 1 to 5 millimeters. The maximum it's going 5 millimeters. So you can just see in some of different type of fragments, holes, a microbial, like you can see in here hydrothermal chimneys open in there, and some of trags fragments in here, like bio-eroded cases, and also in this corner you can see some of tubular formation. Still there are a lot of arguments and what it was really like, because of in this corner to the whole image. Actually it's something like really dark, but finally what this NASA and other institute, what they have been just done, they just opened this data for the different astrobiologists in the world. So we also taking the some of part of this case to explanations. We have been just cooperated with the China, Morocco, and India also. So and here also like some of like sedimentations or microbial formation, but exactly not sure. But it's up to us to explain by using the some of a simulation technique what it was like. Is it fossil or living? model or what sort of like microbial which is relevant to the planet Earth, because of currently we are just find out a lot of details from the planet Earth and different type of extreme conditions which is sedimented with the fossilized with the microbial activity. So we are just going to be compare those data with the Mars, but it can be not 100% accurate. That's what I already told you, a systematic comparison in between two planets, because we don't know those extreme conditions are similar. We are just trying to be just compare to different extreme conditions places, that's right. But however, it's very important case. If someone interested to read those things, currently you can just search on the Google tubular structured hematite hydrothermal vents on the Mars, because of there are two terms like hematite, it means like content with the iron, and also same things we are explaining we call blueberries. I will show you. Here you can see some of black color object in here. These are the parts we call it blueberry. Still there is no definitions to the exact definitions to the other item. There are a lot of blueberries on the meridian planium, so still scientists don't have any idea how it's occurred, but currently we have been just introducing new hypotheses. You can just read on that paper and the technical report to having just having some of idea of the this kind of thing. Actually this is very interesting fact. I hope currently now you have a fundamental and preliminary idea of what astrobiologists are doing, things that they have to be just find out explanations. It's so challengeable actually. Some of items are very newly things to explain, even though you know, when you're just heading into this kind of explanation, we need a paleontologist, a trace analysis, some of like microbial sedimental analysis, and there are a lot of scientists. We need those ideas to put it one bucket. And however, finally it's very important, but the most important case, these are our team explanations of those things. This year we have been just incorporated with the Mars Society International Conference. So same time there are some of arguments at the moment actually because of some of hypothetical things that we have been just introducing for the Mars meridian period. Actually at the end I mentioned it like we call it a 𝗰𝘁𝗶𝗰𝘁 formation on Mars. Actually this is the first singular term in the astrobiological collection we have been just added, because of I think most of students in here, they know how to create a 𝗰𝘁𝗶𝗰𝘁. It's something like our sweets, and we need some of powders, like we need steam, we need water, and but the formation it's very interested one because of some of very tiny balls. If you are just can be just looking from the microbial lenses, you can just see in very tiny balls in the 𝗰𝘁𝗶𝗰𝘁. But why it's happening, it can be with the denser. If you are just putting a lot of water, the sizes of that small balls can be changed. It can be like bulk, but with the less water and different type of heat, it can be changed, even though taste also change. But same phenomena we are just discussed on the planet Mars, but it's just an example for simulating. This is the first time we have been just done for the, because of it's contaminated with some different type of mineral. There are a lot of minerals and also water, but water it's having some of huge toleration effect because of the changes of the temperature. Because of day and night, it's a huge gap in between temperature and directly affecting to the some of surfaces bodies, as I already informed. That is a part we may have to be just think. So explaining that those blueberries, hematite formations on the Mars, so we have been just used that a new hypothetical concept that white vapor formation known as. It's a very interested one. However, there are a lot of scientists are just arguing this. But anyway, technically there is a huge sounds on it. But currently also we are just working on this case. And also right now I'm just trying to be just shifting to the another part before I end in my session. I hope I have another 20 to 30 minutes because of currently I have been just discussed something like history of the astrobiology and what's happened on the prehistoric time and the application directly incorporated with the astrobiology, especially a simulation part. And the third part in here, what I need to be just explain things originally we have been developed for the astrobiology, but the later on the application we can be just apply for the different type of subjects to giving answers for different type of matters. So it's called a ULF, actually a preliminary ultra low frequency, a wave that used in the NASA at the around in 1960 decade when scientists are going outside of the planet Earth. If it is something happen, they just develop very special water treatment, like energized water for drinking to the scientists. One thing, it's added some of energy. Other one is it's controlling the some of like a blood cell. We call it like a metabolism, controlling for the it's actually it's upgrading the metabolism. You see, like the practically currently you just vaccinated because of you need to be just upgraded your immunity. So that is something like very good example for this case. For this is upgrading metabolism. It's not, I think, increasing. We can't, because of your vision you can't increase by using vaccine, or you can't increase in your immunity for vaccine. It's a little bit upgrading and adapting with the conditions. However, what I need to be just explain, currently we use same application for sort out different type of industrial cases. On 2014 we have been just incorporated with the one of institute, actually it's a research institute in Singapore called 𝗂𝗃. They are the one who just introducing this technology. After that same technology hand over to the Sri Lanka also, like South Asia region, and practically we have been just try with our water sources. Why? It's using, you know, industrial level there are a lot of chemicals we use in for the when it's generating the steam. I hope if it is some of engineering student in here, they do have some of idea. Because of especially like boilers and cooling towers in Sri Lanka, they just using a lot of a chemical to control like corrosion scales and biofilling. But the same ULF treatment, we can just control those things by apply with some of like a non-chemical water treatment. Actually that ULF, as I already told you, ULF originally designed for the sum of like controlling the metabolism of the astronaut, but later on with the sum of modification, same application we have been just apply for the different type of cases. And also currently we are just thinking to giving some of solutions on where it go. This is using the same application because of currently there is no medicine for this case, and Sri Lanka also we are working on it. And I need to be just explain like ULF also in the industrial level there are a lot of company currently apply for the ULF solution, but I'm just unable to say some of name because of those things are just heading as some of a commercialized project. However, it's really interesting. As an astrobiologist, I'm really glad because of something that originally we have been just find out from the astronomical scenario. Later on we can be just apply for the sum of a general industry. It's very important case. And also same time they also just introduced that a water, special water by using the ULF. It's like almost energy drink. You know, there are a lot of energy drink in the market, but this is the first energy drink which is incorporated to the astronomy. I hope within next couple of years in Sri Lanka also you can just see in this kind of product. And it's very glad thing. This is a part you may have to be just think, because of when we just put it astrobiology like subject in Sri Lanka, you may have to think how we just paste in here, because of, you see, if you become one day astrobiologist, so if you are just arrival to the Sri Lanka, still we don't have any place to work out, because of there is no astrobiological or pop-up industrial level, or like even though academic level we don't have any applications to run in Sri Lanka. So in fact we do have a missing link for the job space as astrobiologists, even though planetary geologists we don't have. But the things you can do, having a different idea with the applications on astrobiology and introducing to the field. So that is how we're going to be interconnected with the commercialized things, because of we don't need to be just deviate with the other objective, because of objective of the astrobiology is finding life beyond there. That is the master case. So but keep that objective also, same time you need to be just think that part also. So I think when you are just put it this kind of subject in South Asia region, this is very interested part, because of we can't just having astrobiological societies. I mean society means like a culture, astrobiological culture like USA, Europe, because of originally they have some space to job. But however it's going to be so trending. India also doing a lot of things currently. We also just cooperated with them, and also some of other countries like Chile and the UK and the Singapore, and there are a lot of scientists who around the world that cooperated with us. However, it's really interested, and same application we have been just applied to the virtually coal plants. I'm not going to be explain like depth of this project because of it's very interesting project. However, with some of commercialized thing, it's not still finalizing. But I really interesting to inform like the application that we have been introduced, it's technically accepted. That is very something like a proudable thing, because of the sum of things originally developed for the astronomical cases. Finally we are just able to apply for the different type of cases. This is the layout. I'm going to be explain this case. However, if someone interested in this case, like you can just find this technical report from the Google, extreme low frequency and basis of the biofueling control, how we're going to be just apply for the Sri Lankan industry. You can just have in some of very preliminary idea, so you can just head in on it. And second one, another extreme conditions that we have been just studied, because of currently I'm trying to be explain all the applications that we have been just running on the Sri Lanka as well as South Asia region, especially like Sri Lanka, because of there is no simulation that we have been done in Sri Lanka yet, but India and other countries we just processing on. However, this also really interested one. A couple of years ago we have been studying some of organic compounds and inorganic compounds of the meteoritic materials, because of when a meteorite arrival to the planet Earth, so it's having some of huge collapsions. When it's having impact with our atmosphere, definitely it could be burned and very tiny and small part just arrival to the surface. So however, it's very interesting, and there are a lot of minerals contained with those meteorites. It's up to us to study what kind of minerals in there, if it is any life forms, and what kind of thermodynamical activities which is happening on that period, because of when it's entry, it's approximately 600 to the 1000 centigrade, it can be just burn out. So those minerals can be changed with those those heat. because of currently when it concerns of the sum of rock, we can just find out like igneous, metamorphic and sedimentary. Those are some of a basic type of rock. So then we have to be just find out those meteorites with the heat, which type of rock formation it belongs to, why it's having this kind of mineral. So what are the things that we can do? Because of same time many scientists are interested in study of the life, if it is some of a microbial life formation around in those meteoritic items. Then other side we can just study, no doubt. But same time what my QV used to study thermodynamic parts on this, right? Because of how those minerals are changing with the heat when it's having an atmosphere entry. This is something objective. So you can see what my part is study the aluminium oxide of those meteorite, because of aluminium oxide is a good resistant for the heat transfer. Make sure to remember, if it is any microbial organism contained on any kind of meteorite, definitely it should be contained in the aluminium oxide, because of it is something a protected layer for if it is organic compounds like microbial or whatever the thing. So same scenario we have been just applied for the industrial level, how we using that technology for a newly developed a gem treatment. Actually this is from the part of the ionic meteorite. It's not from the originate from the planet Earth, it's coming from the outside of the planet Earth, stone iron meteorite. And however it's really interesting because of why it's happening, because of meteorite entry and changing of the heat, thermodynamic actions. So same actions we have been just note out, yes, these are the measurements, it's happening with the sum of meteorite entry of the planet Earth. Then what we have been done, we just applied same measurements in artificial chamber to the gem. In here you can see the log, we have been just now technology for upgrading low grade gems to the high grade gem. Because of this is something like a multidisciplinary application. It's not only the astrobiology. I just like I explained, because of it's really interesting part, because of I'm also very curious to doing some multidisciplinary application. Currently this part also just running on Sri Lanka. It's not like, but however it's something very interesting to the field, because of it is something, because of the originally data and measurement, all the things where we just gather because of those meteorite when it's having a meteorite entry of our atmosphere. Really interesting thing. And also actually the turning point of this project, I hope you guys remember there are some of meteorite showers and some of microbial items have been just fossilized with those meteorite, have been just informed Professor Chandra Wickramasinghe around in 2012 to 2014, especially like Aranaganwila case. It's something like very dominant case, and he just recorded some of fossils diatom also. But still, even though there are a lot of arguments in this case, actually he just discussed the same phenomena in 2012 in that astrobiology conference in the University of Peradeniya. But however those are the things that we have been just having discovered in Sri Lanka. Because of, you see, if someone interested in direct astrobiology, you can just go through with these things and find out the materials and can be discovered, analysis and having some of data. At same time you can just deviate from the indirect astrobiology, like the things originally you have been just developed for the astrobiology and just try to apply for the another field also. That part's also really interesting. So at the end, I'm not going to be explaining this part because of planetary geology. I have been already give some definition, because of we are just going to study a solid surface. So I'm just wanna give some very simply explanations on one part. based on our moon. Currently, we are working on some of projects of the extraterrestrial mega landslide and simulations with our subregional beds. And make sure to remember, planetary geology is studying some of solid surface objective on any kind of planet, even though our planet, because of it. That's why I told you, if you are just living in a Mars, so our planet Earth is going to be extraterrestrial. So that is how systematically comparisons of those things. However, it's really interesting. It generates a lot of things. Basically, these are the things that we have just studied on the Mars, like highlands, like some of very high altitude places, like marine seas, whales, like some of volcanic activities, and also impact of the craters, some lava tubes. Actually, currently you can just see those kind of landscape on planet Earth also, because of there is one thing I need to be just explain you. That's why I just wrote in these slides. However, it's very interesting part. So because of the scenario, if you really not want to study of the sum of really life, it's very important. However, most of scientists are just explained that life it's depend on the water, but practically still I don't have understanding behavior of the water, H2O, because of it's so complicated. I have been, I think, more than 4 years I have been working in that ultra low frequency treatment that's developed by the original developed by NASA. The way of reactions of the water, it's so very it can be, sometimes it can be changed into the, like, even though those energized water, we can change hematite to the aragonite, like some calcite to the aragonite, and some of hematite to the another different stages. It's really interesting. So however, in this factor, this is out of the water, there is no water on Mars, but study of the sum of surfaces item, it can be simulated. Some of another bodies on a planet Earth, you can see in here different type of things. Actually, those kind of landscape available on the planet Earth also, how its formation, why it's going to be high altitude mountain, and what kind of volcanism activity. That's why I told you a basic idea of the geology and the rock, like, so example in here, the building the composite, a volcano. So it means if it is any igneous rock or metamorphic or sedimented. So those are the things that we may have to be just think. In here also you can see another visualization, very interesting part, because of this is the part I need to show you. This is from the moon, and very special site. Because of why this is important, this is something very specific site that we have been just used for study the landslide, a mega extraterrestrial mega landslide on the moon, and same time Mars also we just use as a very simulating place. Actually, NASA scientist called Agilina. She is the one who just like a pioneer scientist who doing the things. Later on, we also using some of her modules for doing some of simulation in here also by using the alluvial beds and other things. Just explanation in here also you can see some of land sizes are overlapping. You can see that old light mantle and young light mantle, it's a overlapping part. So I'm not going to be explaining all over the things. However, it's really interesting part to study all over the thing, not only the moon and especially like Mars and all the things. It's really great. And this is something like previous image that I already represented from the Ladakh as our simulation site. And also you can say this is something like very interested model from the Mars that developed by Galina. And also you can see the next image, it is from the Sri Lanka. Actually it's something like simulation model, that one also, but paleo environment. You can see that Adams Peak, Sripa there, and also in front of the sum of mountain, which is considered the alluvial bed because of those sedimenteds. all the things. It is contaminations with the alluvial, so very interesting. And there is some of technical reports. Still this part is not released, most probably within next before 2020 this technical report will be released as a book. And if someone interested in astrobiology and paleontology, I think this is something like good guideline for you study in Sri Lanka. Actually it's a free of charge, you can just take it from the Department of File Lab. They are the one who just authorize people for printed this copy. And I think this is something going to be like a very interesting turning point in Sri Lanka to study astrobiology and some of paleontological things and the simulation project. Actually these are the some of preliminary things I need to be just explain. So thank you very much. So basically I need to be just explain, as I told you, history of astrobiology and what is the role of the astrobiologist, and same time the direct simulation applications of the astrobiology in planet Earth, and how we're going to be just doing the simulation outside of the planet and as well as planet Earth, and the same time the multidisciplinary applications of the astrobiology, and the also at the end indirect applications of the astrobiology. And there are a lot of things we have been just discussed. I think right now I think I really like if it is something questions is available to answer.
First thing first, thank you very much, Dr. Aravinda, for such a wonderful, outstanding, very informative lecture today. A lot of efforts, not only nationally but internationally as well. That's an outstanding work you are doing, and you are actually still creating with all the efforts that you are like putting in work for the benefits of the knowledge inside and outside. So thank you for all of these efforts. And my question is, Doctor, as you have mentioned, inside the planet Earth, like in Mars or in the Moon or any other planets, we have noticed that scientists, they like, when they are studying life traces in outside the planet Earth, they are comparing it to planet Earth. I want to know, what do you think about these, and if you agree about that?
I think you mean like the simulations with the sum of trace sample. Is that the question, no?
Yeah, exactly, Doctor.
Yeah. It's something like very curious one actually. It's so hard to finding exact answers because of the case. That's why I already told you, like simulating in between two places. It can't be correct because of we are just trying to be compare two different extreme conditions. So there is some doubt, but however with the sum of exact data we can just having a comparison, because of I think you also just part of the actually thank you very much for joining here, because of I think this is the first time I just incorporated in the University of Jagadhanpura. Actually Jodha, actually that event also organized by the University of Jagadhanpura SEDS team. I'm really glad to support these kind of young generations to share in our knowledge and all the things. And same time actually the question that from the you it's like it should be upgrading in the future, because of you see I think the before our report none of our not analysis like a trace in Mars, so that's why they just curious. Also we also have to be do a lot of things, because of it's just a fundamental thing, we need a lot of data, because of currently we have only very minimum data, because of NASA still didn't release some of data. Actually you also know they just pass some of very minimum data, even though ERD and XRD is not public. But however I really like to the things to analysis the analogs things and the like a simulation. But I think with the data it can be changed in the future, because of I think I'm still waiting some of data from the Mars Perseverance rover. I hope they will just pass us some of raw data So after that, we can just clarify something deeply idea for this Mars fossil. Still, I believe it really possibility to having a fossilization on Mars. It is possible. So it means it's not enough to having images. We need some of chemical analysis, and it's not enough one analysis. Even though currently we have some of chemical analysis from the Mars, but it's not enough strong. We need a lot of data and a lot of research to verify if it is life beyond the Mars. I believe it can be just find out from the Mars. There is no doubt in the future. So I hope, yeah, thank you very much.
Very clear indeed, and very interesting to keep up with this work. Thank you so much.
Yes, sir. First of all, I would also like to say that this is a very informative and interesting session. Sir, my problem is, why hasn't there been enough interest among even the scientific community to use Titan, the moon of Saturn, as experimental ground for primordial life? Because there has been lots of discussions, because the nature and the geology and the chemistry of the composition and the composition and of Titan is extremely similar to primordial Earth. So why hasn't there been like much interest for using Titan as a experimental hub?
Yeah, I think it's good question, and also content with your question. Actually, you also give some answers. Also, it's really interesting. Actually, the scenario why they interested, it do have some of a similarity of the primordial soup, and also because of why most of astrobiologists and all the people interested in other planets, because of water. That is the basic and the fundamental things that they are looking for. And even though water can be just stay like, even though gas mode, like solid mode, like ice and all the things, and especially like concerning of the atmospheric condition, which is similar to our planet Earth. It not only the today conditions, like Ravin said, it can be just having a very prehistoric time also. That's why we had to be just concerns of the life, like some of evidences from the Venus. Because of there are some organic compounds on atmosphere on Venus. So after next 4.5 billion years ago, we don't know what will happen. But the only case, we are lacking data. Saturn and Titan, and especially like Enceladus, also have similar activities. But unfortunately, we are lacking data. Currently, we just having some of rich data from the Mars. But it's misleading a lot of data. Currently, you see, we also analysis in the third time some of Opportunity rovers data, and it will be just trigger new things because of I think now some of space institutes, like very highly standard space institutes, they are just open with the other scientists to having some of idea. It's really good thing, I think, because of it will be just good directions to opening some of sharing the hands to the other institute, and at the same time it will be just having a good ideas of the conditions of the Mars and all the things. I think Ravin, you just clear my answer. It's very simple answer, but we need a lot of data. And a lot of data means like very exact data, like chemical data and the physical data. It's compulsory to get the idea. There are a lot of planets in like natural satellites which contain with the very similar activity of our planet Earth, even though that prehistoric time. So it's really curious. In the future, I hope we can just find proper answers. Yeah.
Okay, sir, thank you.
Yeah. So as I told you, like if anyone having a question from the single language also, it's open. It doesn't matter. If someone, I'm not sure if it is a question from the chat box, I can answer. Let me check the chat box.
Yes, sir. There are some questions in the chat box as well.
Yeah, yeah. I will just answer in the some. There are some of similarity question, but randomly I will select some question. Actually, one question from the student. Yeah, how to become an astrobiologist. Actually, astrobiologists can be like a geologist, a paleontologist, because of, even though if someone interested in a biological stream, because of for the A level, if you are studying the biology, I think it's better after that you can just select some of a geological stream in Sri Lanka, because of especially you can just try on the University of Peradeniya, the best place to study geology, as well as a physical science also really interested, but you need to be just interconnected. Like for the undergraduate degree, if you are doing something like geology or something like biological related stream, so the MSc also, it's better you can just interconnected with this part. And same time you have to be just apply for the maybe PhD or MSc for outside of the Sri Lanka. If it is like to be like paleontology or microgeology or like sedimentology, or there are a lot of things, but it's so easy to head in those fields to like microbiology. As a microbiologist can be an astrobiologist, a paleontologist he can be like an astrobiologist, like a geologist easily he can be like an astrobiologist. So basically you have to be just find out what are your next academic steps to do, and the same time it's so important to do some of practical research and involving with the some of specific group, university or institutions. So that is the most highly advanced part, because of anyone can explain astrobiology after. You see the currently how people are just doing in Sri Lanka, Google and some of lot of social media activities, and you can just go through and doing the things and finding the some of specific answers. But the why we important to run in specific field, specific discipline, that is how ethically, academically we are just looking for. But currently in Sri Lanka we don't have any degree from the astrobiology, but I'm really glad to say if you are really interested in astronomy, now University of Colombo is open for the even though PhD level. It's available something. It's a very good opportunity for people who are interested in astronomy. And also same time I need to be explained, even though like if you are really interested in engineering field like maths and all the things, you can be just selected for the like mechatronics, robotic science, artificial intelligence, or whatever the thing. And also he also can be like supporting for the developing astrobiology, even though a couple of years ago one of scientists we have been just discussed from the, he's working with the NASA, and actually Dr. Majda, he's the one who just introducing us. But the part of the his work is designing a robotic part for the Mars explorations program. But he do have really good knowledge in astrobiology and what will happen, and because of exactly you have to know what is the part you're going to give solution. Because of, yes, I am one who just engineering in the robotics and designing the robots, so I do have to be there's some idea what are the things that my robots doing. So what kind of parameters taken, is it taking some of like XDR test on the Mars, or like X-ray test on the Mars, EDR imaging on the Mars? So it means he need to be just some idea of the Mars surface also. So I mean anyone student who really interested into this astrobiology, you have to dive the subject. That is something basic things, and same time you have to be just complete your academic qualifications also.
Yeah, my question is, like everybody says like this whole universe is stable, right? So
Yeah.
my question is, if we want to find an outer living being beyond the earth, can't we like track I'm thinking like if there's a planet earth, like it's in the universe and it's stable, and of course there should be something quite opposite to the planet Earth, and also quite opposite to the structure of these living beings. So I'm just asking, like, can we track using these kind of logical things, like, at one of the books from Dr. Rosa, I've read, like, don't touch, if you see an alien, don't just go and touch him, because if it is, if that person, that alien could be the quite opposite of you, and then you, both of you will get vanished, and something like that, because always things are stable due to some kind of it quite opposite thing. So I'm just asking, like, can't we use that thing to track the some other kind of living beings, like?
Yeah, I think it's combined the few different field, because of I think your questions is directly belongs to the cosmology, not astrobiology. But anyway, it is a really interesting part. Actually, I will give you some of example. Like once we have been done one of simulation in Sri Lanka and as well as Singapore by using the stalagmite and stalactite. It means like you have been just seeing how like from the singular, what we call it's like Hiritambar and Hirilamba, two different like calcite formations in some of places. It's a really interesting one. So actually that is the same thing you are just explaining, like the side and the opposite side. But actually those kind of, because of it is something like when we are explain the sum of like a designing of the universes, that is something like a common phenomena. But however, when we are just doing the exact data with the astrobiology, we need some of our physical things. But the things of the tracking the things that ask you just doing it something like actually this belongs to the cosmology. However, it's really interesting if you are just studying the some of factors of the like what Einstein said and some of other the studies. It's really interesting. But however, it's highlighted one thing because of what it said. We can't just compare to different places. That's what I also just mentioned in the, because of two different extreme conditions we are unable to compare. But currently we are doing it, even though NASA and all the people, we are just compare. Yes, we have this kind of structure from the Mars, and we just trying to be just find out which structured in planet Earth which is similar to this objective. It can be possible, but the things that you are being highlighted, it is the opposite side. So it's really interesting, but in the future we have to be just find out a new technology how to track in those kind of things. Yeah.
Thank you, Doctor. Thank you
Yeah,
so much.
yeah, welcome. Yes, okay.
There is a question. So I am studying mineral resources and technology. Do this field have a connection to space science like planetary geology? What are the steps do I have to take to become a planetary geologist?
Yes, if you are really interested on the minerals and all the thing, it's really like having some of space in like a planetary geology. But professionally, if you really need to be like a planetary geologist, it's a position. Because of if you need to be achieve that stage, basically I hope if I study in the minerals and all the things, it can be like a geologist or geographer, or maybe like I'm not sure what kind of student you are. However, it's having some of opportunities, but the fundamental discipline and the undergraduate degree that you have been just follow up, it should be having interconnected with the requirement of the job position. Because of exactly we have to know what are the basic qualifications that require from the like those kind of the field, especially like NASA, ESA, or whatever the institute, even though there are some lot of institutions in India also. So maybe they asking you, yes, as a general degree you need these are the components you have to be just complete. Then the master, these are the things, and after the PhD, these are the, but without PhD there are some of opportunity. However, the things practically that you're doing right now, it's very important because of currently we also study 𝗄𝗵𝘁. I think you just heard like 𝗄𝗵𝘁 analysis on the Mars. Actually, we are just also just taking some of part for analysis those minerals. It is really interesting because of the fundamental things. It's really important, and you have some opportunities. As I informed, just try to be study with some of outside link. What are the requirement? So then you can have in a very easy idea. Yes, I need to. My next step should be this. Then exactly you know it. Yes, I hope it's clear. So then I think 𝗰𝘁, I think there are someone just raising the hand. It's better give him some opportunities to ask. It's Dalita. Yes, Dalita. Then we'll shift into the chat box. Dalita. Yes.
I have a question. Sir, show two landscape of Mars in India and Sri Lanka.
Yeah.
In Sri Lanka, 𝗰𝗰 is all are same to the real Mars.
No, Dalita. Actually, 𝗰𝗰 is not like it's a landscape. That's exactly true. But it's not like similar, but some of formations in India like alluvial formation and environmental conditions and the some of area that we are compare in Mars, it's so similar, but the reconstructed image that I show you of the Sri Lanka by using the Adams Peak and other thing, that part is very similar to the Mars, but it's not current condition. Actually, that Pleistocene is to approximately like 1 million years ago in Sri Lanka. That conditions it's little bit similar to the current Mars condition. You see, that is the part we may have to be just think. I think it's a good question. Why 𝗰𝗰 we selected? Because of it having a different type of geological formation. Because of that Mars also have the ferrous based contamination on the surface. It's very really interesting thing. That's why we select 𝗰𝗰 as a simulation point. But 100% none of places are not similar. It's only simulation. I hope Dalita you're clear. Yeah.
Yes, sir. I'm in Sri Lankan people told 𝗰𝗰 to the landscape have come a meteoroid because of a magnetic that meteoroid.
Yeah, I clear your question. Yes, there's actually it don't have some of magnetic formation because of there is no magnetite because of it's contained on a serpentinite like a rock because of it's something like in the border of the highland complex. It can be occurred because of the volcanism activities at the very prehistoric background, not currently. The volcanism activity happening maybe millions years ago. So, but currently we just find out only ferrous. It means iron-based minerals around in the serpentinite. But some of us just argue, yes, it's coming from the meteorite and all that, but some of strong evidences by even though in Sri Lankan geologists they have been just proven no, it's a serpentinite because of some of geological activities in previous our tectonics in Sri Lanka. So I hope you clear answer.
Okay, sir. I have another question.
Yeah.
Sir, is there 0 degrees to watch the sea level in underground in Sri Lanka?
I didn't catch your question. Is there any
0 degrees to that means, but when tsunami comes towards the 0 degrees in sea level?
Yeah.
In Sri Lanka?
Yeah, you mean as like possibilities to the plate tectonic actions and the tsunami reaction. Is that so?
Yes, sir.
Okay. Yeah, I think currently we are not located in very close to the tectonic activities. You can just go to the Google and just search on tectonics, geological tectonic plates, and then you can just see there is no tectonic plates very close to the Sri Lanka, or we are in some of Indian plates. But if it is any continental located in very close to any kind of plate boundary, so these kind of countries can happen like volcanism activities and the tsunami warning. But I think you guys also just remember in 2004 we do have some of experience of the tsunami. But if someone interested for this case, once even though each every day there are some of earth quick reaction because of why tsunami happening with the some of earthquake bottom of the earth, it can be increasing because of the depth and the type of the wave. And the if someone interested, actually the Geological Mines Bureau in Sri Lanka, they do have some of earthquake monitoring, like real-time monitoring system. So I think
it is in underground. It is in underground like
yes,
that one.
yes, there is some of just in some like a sea bottom. It's going to be like uplift and different type of layer, and that's how it's happening. What I might just suggestion, if someone interested, please visit to the GSMB, Geological Monitoring. They do have some of real-time monitoring system, how it's earthquake happening and all the things, and you can just see it.
Sir, how can we identify there? I mean, Sri Lanka. What is the place we can see this?
Actually, that's why I told you, if you're really interested, please visit to the GSME, because this is not astrobiology question.
I think so.
But
in
yeah,
tsunami period, my father went to the underground and see the 0 degrees. I can't remember the place. I think what is the
okay,
Coal Fort place like
okay.
no.
Yeah, that's why I told you, it's someone interested in some of activities in earthquake and all the things, how it's happening with the real time. Please visit it to the GSME, because of they have real time all the things monitoring system in currently. You can just see where the earthquakes happening, not only the Sri Lanka, whole around the world, and what kind of effectivity to the Sri Lanka. You can just clear, even though how much depth and where the exact locations, all the things, it's possible. So it's really interesting, because at the very previous time they don't have this kind of thing, but currently it's possible, even though if it is something like a tsunami thing. I hope they can just have an idea. Actually, this is something out of the other astrobiology question, but I just answer the things that currently I know. I hope that you clear.
Okay, sir. Thank you, sir.
Thank you again, sir, for sharing valuable information with us. It was a great, interesting session. So I think that by joining this important session, you were able to add a lot of facts about astrobiology and planetary geology, your knowledge book. Not only that, but by continuing to stay with SEDS Chapura, you will have the opportunity to attend more exciting sessions and workshops. End of the Introduction to Astrobiology and Planetary Geology session, organized by SEDS Chapura. Thank you for joining us and have a